Hi, my name is Aaron Luke. I'm a developer here at Pixar on the USD team, and I'm going to walk through some workflow demos that show the composition features of USD in action, like we discussed earlier with references, variants, and overrides, and how they interact to define aggregate models that travel throughout the pipeline here. So to review, we'll take another look at our individual model that we saw earlier, the alarm clock. Here it's its source geometry in Maya, and it's exported USD tags it as kind prop. By contrast, here is the set in Maya, and its USD has it tagged as kind set. Intermediate nodes are called groups, and then the props themselves, you see here are references to their corresponding USD files. Here's the book dorm, as well as opinions about its modeling variant and transforms. If we bring up that same book dorm here in Maya, we'd see the variants that are available. So let's go through a typical set dressing workflow. We'll just go ahead and add a prop to the set. We'll take our alarm clock mic, reference it into Maya. We want to group it with the other props on the desk surface, so we'll drag it under that group. And then we'll do initial placements here in Maya, and we'll see how this travels along the pipeline. We have this same version of the set with the clock. We could, in Presto, reread our references here. And the text file I was looking at earlier is also being exported as well, and we'll go ahead and refresh that buffer. And we'll see that now we have a reference to the alarm clock mic in the set, as well as a transform that we authored in Maya. It's now available to load in Presto, and we load it. It's where we put it in Maya. So now we can go ahead and do some camera dressing in our shot context in Presto. And as we could see that what we're actually writing here are just sparse translation and rotation values over the reference. So as this travels along the pipeline, we don't have to reflatten the file out. Okay, great. So let's say we've been asked to make a modeling change to the prop, and we'll go ahead and do that here, just a trivial little second hand. And we can export the source out of Maya also directly into Presto via the reference to the set, which references the clock, and now we see our second hand present in Presto. Let's say we want to see the clock in context with and without that modeling change. So we can define a modeling variant for that here. As you recall, variant is like a switch statement for scene description. Here in Maya, we're doing it using visibility sets, but you can think of it like scene assemblies in Maya, just multiple representations at the same area of namespace in the scene. So we have with seconds and without seconds here, and without seconds we'll have the second hand actually deactivated in the composed USD scene graph. It's not just being invised in the resulted USD, it's actually being removed. So now when we go ahead and we can export our version with the variant, we can reread our reference in Presto, and we can see now that we have a switch available with seconds. We flip it to without seconds, the second hand disappears, and if we flip it back, it reappears, and all we're authoring is a string value for the modeling variant with seconds and without seconds over the reference. In Katana, the same asset has the switch available, and when we flip it from without seconds to with seconds, both the interactive render and the offline render now have the geometry for the second hand and the shading appropriately. The same concept of sparse overrides or references also applies to how we export animation out of Presto. Here you can see, in this shot, we see all the characters being posed by their character rigs that are defined in Presto over their USD geometry. Here, when we've exported to Katana, we don't want to pay for the rigs. We just want to see the final posed geometry. So what we've exported are per frame the final point positions and transforms as overrides to the reference models. So if we look at the USD, it would look something like this, where we have a reference to mic, and then for each frame, there's a value for transform and a value for points. Throughout these demos, you've seen the set, and that's been drawn with a proxy renderer that just basically just built up VBOs for USD. It's not another file format. It's just another small library alongside USD that can traverse the scene and produce VBOs to send to GL. That's how we're drawing the set here in Maya, the set here in Presto, and the set here in Katana, as well as the animated characters you saw in Katana in the previous example. So like for those cached character animations, we can also bring them back into Presto as stand-ins. For example, say you're animating on Sullivan and you don't want to pay for Mike's rig, you can use his cached animation. Or say you're putting together a bunch of crowds, you can use cached animation clips to assemble crowds. For effects, we're primarily using Houdini, and we can import USD as input meshes to simulations in Houdini. And what we export can vary. We can override or redefine our input geometry. For example, we can sparsely override hierarchical subdiv tags per frame to remesh it. Or we can generate a new asset. We can add a new element to the shot to interact with our input mesh, like rain, and export that to USD. Or if we're doing some very large-scale remeshing, we may choose to just flatten out the whole scene graph and write out per frame. But the key takeaway is that as USD, these simulation results can go back up anywhere else in the pipeline. We can drive secondary simulations with it. We can send it to Presto to give the animators a preview of what their characters are interacting with, and so forth. So that's just a brief survey of some of the uses of USD in our pipeline, and how it really kind of inlines the import-export process that our TDs use so often to see their work in context in other workflows in other tools. So thanks for listening, and please give us any comments, feedback on the Google group. Thanks a lot.